I am partway through the process of constructing my mold, and I'm really goddamn annoyed with making this shit. Fuck this thing. This thing is such a bitch to make. Check that out. I actually got it together. I think it is time that I take this concrete tube apart. Hey guys, what's up? I'm back again with you with another fucking video, Lavish Moss guys. Haha, yeah. Of course, today I have another cable machine video for you because I am sort of a cable machine enthusiast, a cable machine god if you would. This one's going to be a little bit different because I've made a couple cable machines for you on this YouTube channel in the past. So I have both of those cable machines, and those were great to build, but I believe a problem that a lot of people were having is that they couldn't actually build that. First cable machine I made was really expensive, and it takes a lot of metal work. Second one takes a lot of metal work, takes a bunch of skills that a lot of people just don't have. My idea is that I should make a cable machine that truly everybody could potentially make from their own home if they really wanted to. This cable machine is wood, and it has a custom DIY weight stack that costs fucking $50 to make, and that weight stack is going to be made out of concrete, alright? Concrete is a really cheap material that is pretty heavy. It's not as heavy as metal, especially steel, but it's still pretty goddamn heavy. So if you want a selectorized cable machine weight stack in your possession that you can use, that is not gonna cost $2,500 fucking dollars, then this is the video for you because I'm gonna show you how you can actually build one. It's not that hard. It's gonna take a couple of things, but you can do it. You guys at home could probably build it much better than I have built it here. So let's get into it.
I'm using the CNC plasma table to easily cut out all the flat steel pieces I'll need for both the weight stack and the wood cable machine. I used a CAD program called Fusion 360 to design these parts, but there are a variety of different programs you could use. Even though I'm using this expensive piece of technology to cut my steel, you don't have to. I'm only using the table because I'm too lazy to hand cut out all these parts. You definitely can cut out all these parts by hand using an angle grinder and some measuring. A lot of these cuts are only for looks and not actually necessary for the functionality of the machine. For these pulley brackets, for example, you don't have to do all these intricate interior cuts. You just have to cut out the general shape and drill a hole through the middle for the bolt.
I have two 3.5 inch pulleys right here that will go in this hole and this hole once I drill them out, which will create the user interface which the user of this cable machine will interact with. This is the bracket here, kind of sandwiches the pulleys like this. 1 inch plumbing pipe. I'm gonna weld it here like this. It is going to create a pivot point so that we can mount this bracket on a pin, which will be a bolt. This is the pulley bracket that will mount the pulley to the weight stack. It's a big pulley, it's a 6-inch pulley. It doesn't have to be a 6-inch pulley. And this bracket is going to go together like this. You got one side on the bottom, one side on the top, and then you have this piece, another piece that I cut out, which I will weld on the bottom. And notice there is a hole in the bottom because I will be welding this or a bolt like this through there. That way we can connect this to the weight stack. I have a 2-inch plumbing pipe that is one of the main support beams of the machine. This piece of 2.5-inch plumbing pipe will be going around it. I cut these out on the CNC plasma table as well. I will be welding these on to this bracket. So the goal here is to, you remember this piece? Is to mount it within these. Mount it within so that this will be able to rotate. And remember, I'm going to be welding this onto this part. So really I'll be mounting this within here, which will be connected to this, meaning you will be able to rotate this piece around. So when I cut this piece out, I just kind of intercepted some other cuts that were already on the plate that I was using. It was kind of like a spare piece of metal. It has this hole in it, and I'm going to patch it up with this little piece of metal that I cut out. Good as new. Goes on here, and it is heavy as it should be. It's going to be a heavy stack, very powerful. It's kind of like a fucking staff. The power of time.
I knew these concrete plates were going to need some strengthening. I thought they'd get smashed up pretty easy after regular use, or even accidentally dropping the stack a couple of times. So I decided to put a rebar skeleton in every plate. I made this jig to make a bunch of identical rebar skeletons. Putting the rebar in every plate also helped me solve another problem, which was where was the pin going to go? A pin has to go through each of these plates. So I had the great idea of using a piece of 1/2-inch plumbing pipe as a sort of pin sleeve, creating a nice smooth hole that the pin can go in and out of.
Hey guys, I am back from the shop and I have 16 of these rebar frames because each one is going into a plate of my concrete weight stack. There's 16 of them because there are 16 plates. Now, what I have to do to these pieces now is, you see how I got this 3/4 inch pipe that runs through it, which the pin will go through. I have to cut this pipe here and here, creating a big hole in the middle, because a pipe is going to be going right through the middle of the weight stack and it can't go through if all of these are going through. So that is what I am going to be doing right now. I have to cut these and I'm just going to cut them with the angle grinder. I think I'm also going to be filing the profile of these pipes so that they're a little concave, so that they can wrap around the pipe when I put them in the concrete form and there are no leaks or no gaps.
What I didn't mention there is how precise these holes need to be. After looking at my design on Fusion 360, I determined that I could measure from the bottom of the 1/2-inch pipe up 3 inches and start my hole from there. I would use the same 2-inch PVC pipe that I would eventually use in the concrete form and this new mark that I made to determine the exact position of each hole.
Hello everybody. The next step that I have to do is make a bunch of plastic bushings that will go inside of the concrete and help it to slide easier on the metal guide rods, which I will be buying from Home Depot. So my goal is to cut 32 2-inch wide PVC bushings out of this 1-inch PVC pipe.
PVC is measured internally, so a piece of 1-inch diameter PVC pipe has an internal diameter of 1 inch. If we use 1-inch guide rods for our concrete weight stack, we can put sections of this 1-inch PVC pipe as bushings, creating a smooth barrier so the stack can slide up and down smoothly.
All right, I got 32 right there.
The concrete form is the most important thing you'll need to build to make a concrete weight stack. I used one 4x8 sheet of this white 3/4 inch melamine, or particle board, because it has this smooth white surface. Hopefully my concrete weight plates will also have this smooth surface. But you could honestly get away with using any 3/4 inch plywood as long as you use a concrete release agent. I cut out all the melamine boards I need on the table saw, then began the long, arduous drilling process. Since the form will have so many pipes going in and out of it, a lot of holes need to be drilled. Just make sure the hole saws or Forstner bits you use are slightly bigger than the pipes you'll be fitting through these holes, because it's likely you won't get everything perfectly aligned.
I am partway through the process of constructing my mold for my concrete custom-made DIY weight stack. And I'm
goddamn annoyed with making this shit. Fuck hole saws. I really hate hole saws. The one piece of advice that keeps coming to mind that I think is the most valuable to give to people who also want to create a concrete weight stack is to not be surprised if you have to do something at least, in this case, 16 times, because I'm making 16 plates. I have to do a lot of these processes 16 times, and it is damn annoying. I don't know if I can take it much longer, if I'm being completely honest. But yeah, I'm just gonna keep going. So I finally got all of the melamine boards that I need to make my concrete form. Took a little while, a couple days to cut them all out, drill out all the hole saw holes, and fuck hole saws. I really hate hole saws. Also, sorry about this rain. I'm in the barn, and it's raining out here in Oregon now. It's getting really cold and raining a lot. But I am finally done making these boards, and I'm now going to make the form and pour the concrete. And I really hope it's going to work. One problem that I'm having is getting everything to fit together. I think it's really important that you buy the right size hole saws for this, whether that be 1 7/8 inch or just a straight up 2-inch hole saw for this 2-inch PVC pipe to fit through the boards. And it's just hard to fit the pipe through the boards and then also have the pipe go through all the rebar strengthening bits that I have. And we'll see if it all works out, but I'm going to build this form now. I'm just going to screw it together with some screws and some pilot holes. I think this wood is going to be very easy to split, so I'm going to use a lot of pilot holes. But here I go. I made this wood block exactly 2 inches thick and used it to space out all the center boards. I also measured and marked a guide on the bottom board to help make sure everything was even. Fitting all the pipes through the form was extremely difficult. I should have built the form with the pipes in place. I also should have drilled bigger holes. If anybody watching decides to try to make one of these at home, please take this advice. Tolerance is important. Drill bigger holes.
Fuck this thing. This thing is such a bitch to make, but I actually got it together, amazingly. Check that out. Ignore that. It goes together. That's just out. I actually got it together. let's say that now I am completed with pouring the concrete for the concrete weight stack. I think it went pretty good. I started off by filling each plate individually, and then I decided to fill all the remaining plates at the same time. And it took around 3 bags, just under 3 bags of 80-pound quickcrete. So just under 240 pounds, which is what I was expecting this weight stack to weigh, which is good. I'm a little bit worried that I'm never going to get these middle PVC pipes out. I use diesel as release agent. I'm not sure if it's going to work because they absolutely do not spin right now. Maybe if I just hit them with a hammer on the end, I'll be able to hammer them out. Who knows? I hope so. I don't think. Check out these geese. It is 48 hours later, and I think it is time that I take this concrete tomb apart. Pretty much I think that it's going to cure better once the plates are separated. At this stage, I believe it is time to begin taking it apart. Good news! Looks like it actually worked. I'm very proud of myself. So here I got 4 stacks of 4, making 16 plates. But I'm just a novice concrete doer. This is literally my first time ever making anything out of concrete. What you can't see inside all these is the rebar frame, which is in every single plate. And I weighed them. I weighed this one, which is the top plate, and it was 15.8 pounds, which I'm very excited about because I can pretty much take off a little bit and it'll end up around 15. I just wanted it to not be under 15 because I calculated that it would be 15 pounds, so I'm glad that it actually is. For the guide rods and a hole that goes through the middle that the selector shaft will go into. Each one also has a pipe that goes on this side, not through the middle, but then continues on this side. And this pipe is for the pin that will go into the selector shaft. But you see, some are better than others. Like this one has some air bubbles. This one has some more. This one has some big ones, and then this one is pretty bad. But all in all, I'd say they're pretty good. The edges are pretty nice. I'm proud of them though. I do think they turned out pretty good. Fuck yeah!